Welcome to Lesson 5 of the Quadratic Functions for Algebra 2. In this lesson, we're going to be writing different forms of quadratic expressions. Okay. So in this problem it says write the expression in the form described. Rewrite our intercept form in standard form by multiplying. Okay, so they're going from intercept form to standard form is all that they're doing. I would just recommend, rather than fill in their blanks, that you come over here and just FOIL or box, whichever you prefer. So if you do box, you would have x plus 2, x plus 5. If you do FOIL, just write out FOIL, and you can go through your steps, x plus 2, x plus 5, and you can draw your lines and multiply. You should end up with this answer, x squared plus 7x plus 10. And if it's so easy that you're doing it in your head, great. That means that you've done a lot of practice in this class or in another one on multiplying those. Now we want to take a standard form expression and go backwards and go into intercept form. And all that you need to do in order to do that is go x squared minus 3x minus 4. You guys have been playing the x game for quite some time. Take your first times your last. Your first is 1. 1 times negative 4 is negative 4. Now we have to think of two numbers that will multiply to be 4 and add to be 3, we say. But in reality, since it's a negative 4, they're opposite signs in order to get the negative when they multiply, and consequently you're finding the difference because they're opposite signs. So we think of our factors of 4. We have 2 and 2, and the difference in those is 0. We have 1 and 4, and the difference is 3. The one that's farthest from 0 always matches the sign up here, so we put negative 4 and 1. Now normally we would do the old man glasses and bring it down to 4-term factoring. However, we can take the shortcut with the 1 in the front here. It means that this is actually put into the answer. And it means this one can actually be put into the answer. Okay? So x squared minus 3x minus 4 is equivalent to x plus 1, x minus 4. Again, there's no need to fill in their blanks if you know what we're doing when we do this. We've been practicing a long time. Describe the product you get when you multiply two linear binomials in the form of x plus p and x plus q, where p and q are constants. Okay, I would actually like you to just go ahead and practice with the algebra there. It's kind of fun to FOIL that. So you get x times x would be x squared plus px plus qx plus pq. Okay? And then you could factor out the x here. So you have x squared plus p plus q times x plus pq. Okay? I just like you to do some of the algebra when they're asking things that way. And basically in standard form, you've just multiplied your two binomials to get the standard form. Always write it with the highest exponent first. In part B, how could you check that you factored the given expression correctly? You could just FOIL or box it, right? Just go backwards. Okay, intercept form of a quadratic function is this. You can multiply to change the quadratic function in intercept form to standard form. You can factor to change the quadratic function in standard form to intercept form. We've just done that on the front page. So again, they want you to break this down. Now I challenge you to just look at your numbers. What adds to be negative 8 and multiplies to be 12? Think of our factors of 12. It is positive, so they'll have the same sign. They'll have the sign of this. So they're both negatives. And we have 1 and 12. Those don't add to be 8. 2 and 6, oh, 2 and 6, there we go. If we didn't get 2 and 6, we'd go on to 3 and 4. And then as soon as we turn back to 4 and 3, we know that we've doubled back on our numbers. It's got to be one of them. Okay, so the x-intercepts are, well, remember for the x-intercept, that's on the x-axis. On the x-axis, y equals 0. So we set this to 0, and we use the zero product property, which we've talked about in class before, which means this times this equals 0, then one of them has to be equal to 0. So we go x minus 2 equals 0, or x minus 6 equals 0. And you can usually do this in your head. We'd add 2 to each side, so we get x equals 2. Add 6 to each side, we get x equals 6. So our x-intercepts are 2, 0, and 6, 0. So the graph includes the points 2, 0, and 6, 0. I guess you could have just put 2 and 6 up there. Okay? Now, the x-coordinate of the vertex, in other words, the axis of symmetry. This is A of S. Let's come down and write the graph, and let's reason this out. See, that's where my y-axis is. There's my x-axis. And we know that our x-intercepts are at 2, 0 and at 6, 0. So if you know that the graph, that the parabola is symmetrical, then you can find the halfway point and put in your axis of symmetry. As soon as you do that, you know the h value of your vertex. That is at 4, so we know that the h value is 4. You could also get it by taking this 2, adding 6 to it, dividing by 2, and getting the average, which is 8 divided by 2 is 4. Okay, now we take that 4, and we need to substitute it back into our original, well, we can use it here, our equation to get what our y value would be, how high up this goes, or how low it goes, actually. So 4 minus 2, 4 minus 6. 4 minus 2 is 2. 4 minus 6 is negative 2. Negative 2 times 2 is negative 4. So the vertex is 4, negative 4. And I just barely went off my graph. So I'd put in that point, and now I'd just connect them to make my U shape. Okay. So now we're given another equation here. This one's a little bit more challenging, only for the fraction. Don't get so worried about it. When you take out 1/3, it will just leave these whole numbers. So we have the x squared, we would have 4x, and we would have minus 5. I'm forgetting one thing. You want to make sure and take the negative off the front as well. So we take out a negative 1/3, that'll change all of their signs. Okay? So now we think of what two numbers would multiply to be negative 5 and add to be 4. Well, if it's a negative 5, you've got a positive and a negative, so they're really subtracting. 5 doesn't have a lot of factors. 5 and 1. Okay? The one farthest from 0 always matches the sign of the middle number. So 5 and 1. So the x-intercepts are 5 and negative 1. So we have 5 and negative 1. Again, you could set those equal to 0 and get this. The x-coordinate of the vertex must be halfway between 5 and negative 1. So we take 5 and we add negative 1. We get 4 over 2. which is equal to 2. Now we'd go down to the graph and try to get this one on the graph. There's our x and our y. We plot our x-intercepts at 5, 2, 3, 4, and at -1. Halfway between was at 2. That was our axis of symmetry. And now we plug in that 2 value to see where our maximum or minimum will be. Now, which will it be? Is it a maximum or a minimum? We've got a negative out front. You said maximum, you're right. 2 minus 5 is -3. 2 plus 1 is 3. Negative times a negative is positive. 1/3 times 3 is 1. Times 3 would be 3. So our vertex is at 2, 3. There we go. Kind of fun to graph these, isn't it? Okay, please come into class prepared to show how to do these intercept forms. You can either direct me how to do it or you can get up and teach it. I do encourage you guys to really help each other, share your knowledge when you get these. Describe another way that you could have found the vertex of the graph of the function in part A. We could have gone into HK format, couldn't we? What we learned yesterday. We could have pulled out that 1/3 and had the -4x, pushed the -5 off the end, divided this by 2, and put it in HK format. In part B, how could you tell that the parabola opens downward? Make sure and think about the sign out front. I think that you can answer that one all on your own. I do expect you to fill those in. Okay. A student claims that you can find the x-coordinate of the vertex of a graph of a quadratic function by averaging the values of p and q from the intercept form of the function. Is the student's claim correct? Well, I think that that's what we do. Isn't an average when we take two numbers, add them together, and divide by the number of items there are? And that's exactly what we're doing, is taking our p and q values, dividing them by the number there are. So that student is correct. Okay, example 3. We're modeling this intercept form. Cross-sectional shape of the archway of a bridge is modeled by the function -0.5 x squared plus 2x, where f of x is the height in meters of a point on the arch. Okay, so f of x means your y is the height in meters. So you need to come down to your graph, put height meters. Okay, of a point on the arch, and x is the distance in meters from the left end of the arch's base. So this is distance from left. And they said that that is in meters. So now we can complete our counting. Every 2 squares is equal to 1, so that would be 2, 3, 4, 5. Here, every 2 squares is 1, so 1, 2, 3, 4, 5. Okay. Write the function in intercept form. Well, we've pulled a half out, so a half goes into a half one time, and we take the negative out with it, so negative times a negative makes positive. That's how we get a negative. And half goes into 2 4 times. Okay? Again, ask yourself how many halves are in 2 when you do that. All too often, students will think that it's 2 divided by 2 and think that would be 1, but it's how many halves are in 2. Okay? Now they're going to also factor out this x, because you've got an extra x in there. And that creates your vertex right there. Or not your vertex, your intercept form. There we go. So the x-intercepts would be 0 and 4. 0 plus 4 is 4, divided by 2 would be 2, so that's your axis of symmetry. Then you'll take that 2, you'll come down to the graph, you'll go over to 2, draw your dashed line for the axis of symmetry, and then you take that 2 value, plug it into your equation, solve, and you should come out with the height of the vertex. Okay, draw your arch real carefully here, because then they have a question for you. Will a wagon that is 2 meters wide and 1.75 meters tall fit under the arch? So you want to go to your axis of symmetry. The wagon's 2 meters wide, so center it. It will come over here and it will come over to here, and draw a box to represent your wagon. It says that it's 2 meters wide and it's 1.75 meters high. You'll have to go up above 1.5, almost to 2, halfway to 2, and draw your box. Then see how it matches up to your arch. We want to talk about this problem in class tomorrow. I really look forward to you having this done. Next up, what do the x-intercepts represent in this situation? When you draw this and you found your x-intercepts, remember this represents an arch. So it's showing where the arch hits the ground whenever it hits the x-intercept. Explain how you use the graph to find the width of the arch at its base. How can you use this graph, once you have your parabola graphed, to find the total width? That's what they're wanting to know. Explain how you modeled the shape of the wagon on the graph. I would assume that you will draw it as a box since they give it as a rectangle. But you can explain more. You may even color it or something. Who knows? What are the x-coordinates of the left and right sides of the model of the wagon? Evaluate the function modeling the arch for these x values. Do the results. Okay, so what they're wanting you to do is over here where the sides of your wagon goes up, they want you to plug that in to your equation. I'd plug it into this one, that x value of 1, plug it in there, and see if it does prove whatever it appears to be, whether the wagon will fit under the arch or not. Verify that it will fit under, that it's less than the amount on the arch. Or if you're saying it won't fit under, verify that it's greater than what the arch allows. Okay? And do that for the 3 as well. Plug it in. Okay, we will be doing the practice tomorrow in class. We'll go over these briefly for questions. Thank you.